Now I am going to talk about what is the concept of resistance that we come across in metals, semiconductors, etc. So what is resistance? So for this we look at the metal solid. We know that there are atoms which are kept at regular fixed distance, and it is the outermost electrons or the valence electrons which are responsible for the conductivity. So when an atom loses the outermost electron, it becomes a positive ion. So I have shown here the structure, the lattice structure of a metal, where we see that there are positive ions which are fixed at regular distance, and the free electrons are able to move in the space between the array of positive ions. So when the current is flowing in the wire, the free electrons are moving between the array of these positive ions. So resistance is called as the opposition to the flow of these charges or the electrons. So what is the opposition if they are moving freely between this space between the positive ions? So here resistivity we saw earlier, that is given by m by n e square tau. Here m is the mass of the electron, n is the free electron density, and tau is the mean collision time. And this can be further written as two terms. One is the resistivity due to the phonon, it's also called as the lattice vibrations, and the second term is the resistivity due to the impurities, that is due to the impurity atoms as well as lattice imperfections. So let us explain this now. The opposition to the movement of the free electrons is due to two factors. Here the positive ions need not be stationary, they can be oscillatory in nature, so that depends upon the thermal energy of the ions. So due to the thermal energy, these ions are actually oscillating to and fro, and if the temperature is increased, the oscillations will be more. So this will affect the movement of the free electron between this space, right? So that will be the opposition to the movement of the free electrons, which is called as the resistance. Now, another factor is due to the presence of the impurity atoms. So some impurity atom may be there in this lattice, that may also oppose the movement of the free electrons, or it may be also due to the lattice imperfections. So this regular periodicity may be not perfect in some region of the lattice, then due to the lattice imperfection also there may be opposition to the movement of the free electrons. So both these factors together give us the factor of resistance or resistivity to the metal. Now if we look at here, the resistivity due to the phonon, it depends upon the temperature, because as temperature increases, the vibrations also increases. So this is directly proportional to temperature. However, the second factor, that is resistivity due to the impurity, it is independent of temperature. Therefore, you see that if I suppose decrease the temperature towards 0 Kelvin, the first factor, the resistivity due to the phonon, also decreases to 0, but this being independent of temperature will remain as it is. Therefore, the total resistivity of the metal tends to resistivity due to the impurity. So this is all shown here in this graph here between the resistivity and temperature. The curve here is going down as the temperature is decreased towards 0, and when it becomes 0, there will be some resistivity left over, that is called as the residual resistivity. So this relation of the resistivity is known as the Matheson's rule. So this explains the resistance phenomena in the case of metals. Now let us see why the classical theory was discarded and why the new quantum free electron theory was proposed later on. This is when we see here that according to the classical theory, resistivity is found to be proportional to the square root of temperature. But experimental results show that resistivity is directly proportional to temperature. So this is one failure we see of the classical theory. Another thing we see is that the conductivity of the metal is given as proportional to the electron density, the free electron density. The more is the free electron density, more will be the conductivity of the metal. According to this, the aluminium has more free electron density than copper. Therefore, aluminium should be a better conductor than copper. But we know that the conductivity of copper is much greater than the conductivity of aluminium. So these are some examples to show that the classical free electron theory does not explain all the facts correctly. So because of this reason, we propose a new theory, that is the quantum free electron theory, to explain the conductivity of the metals.